In this video, we will compare two proof-of-work blockchains, one in testnet, Quai Network, and one already in mainnet, Kaspa. We'll compare them in technical aspects and in tokenomics, and let's just get straight into it. As I already said, both of these blockchains are proof of work. That means there are miners who expend energy to produce the coins of this network. And this expenditure of resources and real-world energy is necessary and a key aspect of these protocols. They're also both polychain backed and also both GPU-mineable. They are both kind of decentralized type of layer ones. This is kind of a weird thing to say. If you think about it, everything in cryptocurrency is supposed to be decentralized. That's kind of the whole ethos. However, we still have this notion of a more decentralized layer one versus less decentralized layer one. And while there is no formal definition of what decentralization means, we can kind of approximate it, operationalize the value by how many nodes and miners are involved in the network and how easy it is for some random Joe to come and participate in the consensus. So there are many nodes who are mining and participating in the consensus of Kaspa on mainnet, and there are multiple hundreds and thousands of nodes participating in the consensus of Quai in testnet. So we can both of them can kind of be considered that decentralized type of layer one, however weird that sounds. And lastly, the point to that is that they are both based on years of quality research from universities. So that's not just an Ethereum fork, just yet another one. They are actually both quite novel architectures that are out there. And now let's go to the differences. One of the main ones, apart from the technical aspects, is that Kaspa is already in mainnet and has been so since November 2021. The market cap of the cryptocurrency at the moment is about $3 billion. And keep in mind, this is not financial advice. Everything I say is just opinions and for educational purposes, just what I find on the internet. And if we go into a bit more detail about Kaspa, at the moment it can run up to 400 TPS. However, it says that about 2000 TPS is possible. Of course, this just depends on the network demands because we cannot really see the maximum TPS unless people are actually doing any kind of transactions on Kaspa with that speed. And one of the key things and one of the key limitations of Kaspa is that it does not support smart contracts. On the other hand, let's compare Quai on these same aspects. So it's still in testnet, not mainnet, and mainnet is planned for summer this year. And in testnet, it is running above 2000 TPS already. And thanks to the technology called Sharding, the scaling is kind of on demand. So the more people transacting on the network, there is a mechanism inserted into the protocol that scales upon a demand increase. So the approximate upper level of TPS is very arbitrary. You can just increase the number of shards and therefore increase the throughput and TPS of the network. If you want to put an upper limit to the scaling solution, you can give it an arbitrary yet feasible number, about 250,000 TPS. However, keep in mind again, you need the number of users and the number of transactions to actually reach that level to go to that number. Because Visa, MasterCard, they are catering to like a big part, more than half of the world, and each of them is running a few thousand TPS, which is why do we even need to have cryptocurrency run above 100,000? Maybe we'll need in the future if they were about to cater for the full world. But if they were to cater for like half of the world, a few thousand or about 10K would be more than enough. But again, we'll see how this works. Maybe at some point cryptocurrency will boom so much that every single person in this world will just start using cryptocurrency, which would be kind of fun, I guess. That would be very, at least convenient to have one currency for the whole world. And I wanted to go about technical aspects, of course, but before then I need to go into a bit more details about how mining works. And I have my notes here, that's why I keep looking and kind of not right into your eyes, not into your soul, but onto my laptop, because I want to make sure I say everything correctly. So let's start with how mining works. You can skip this part if you know how it works, and then I'll go into the differences in the architecture in reference to this mining framework. Firstly, all transactions that need to happen go into the mempool. Mempool is like the memory pool, not like the meme pool, but mem from memory. And there are a bunch of transactions, all the miners that are competing among each other to receive the next block reward are taking a bunch of transactions, ordering them, and then trying to solve a proof-of-work puzzle to be able to append this block of transactions to the existing blockchain. The first miner who produces the valid proof-of-work solution gets a reward in the form of block reward that is defined by the protocol, and also gets the gas fees that users paid for the transactions that are in that block that just got appended. So that's kind of more or less clear, the process, right? However, you might think that sometimes the people who are producing the blocks, the miners, might produce the blocks almost simultaneously. And in that scenario, you need to kind of understand who is actually the first one and whose chain should the people continue. So this is kind of situation is called a fork. So you have a normal linear blockchain, and then at some point, instead of one next block, you have two blocks that are both valid and appeared almost at the same time. This happens especially more often when there are more nodes in the network. So the more nodes there are, the higher is the chance that there is going to be two people producing a valid block almost at the same time. So this is called a fork. A fork, you can think of it as just any kind of the fork you eat your food with. There was one single chain and it split into, let's say, two. However, there can be more, but it's rare and it's beyond the point. Let's think about two points of the fork. So what you need to do, you need to resolve this fork. It's called a temporary fork. You need to resolve it because you cannot just go on and go on. Because if you just went on this way, you instead of one blockchain, you would continue into some kind of infinite tree, which is not what we need. We need one cohesive network. Right. So to resolve that in Bitcoin, there are different blockchains do it in different ways. But in Bitcoin, how it initially worked is that you just wait for another miner to append the next block. So you have one chain, it splits into two, and then you just wait which one gets the next block appended, this one or this one. So let's say on my right hand side, on your left, the next miner produces the block, so everybody has to continue this route and everybody has to continue putting the blocks on top of this one, so you kind of pick this path. And this is called the longest chain rule, and that's how it's done in Bitcoin, and that's kind of how it has been done in proof-of-work Ethereum. And what happens to this block, this poor little guy who kind of got left alone? This is called either an uncle block or an orphan block, depending on the terminology you're using or the type of blockchain you're talking about. In Bitcoin, this is called the orphan block. Orphan block is kind of left alone, as I already said. It is not referenced in the main chain and it does not get any rewards. Whatever name you use for it, uncle, stale, or orphan block, you don't want to have too many of them. And protocols should aim to minimize the number of this kind of blocks, because this is just wasted energy, wasted work that people produced, and it is actually valid work. So it's kind of sad and inefficient to have too many of such blocks. So both Quai Network and Kaspa introduced some kind of mechanisms, and those are different ones, to make sure the orphan blocks are reduced. So how it works in Kaspa is that they take pride in their block DAG architecture. So this looks like this. So instead of going linearly block after block, you can see that in Kaspa blocks may appear in parallel or almost at the same level. And if one of them would have been an orphan block in Bitcoin, it is not lost in this case. It is still referenced and incorporated into the architecture of Kaspa, because it's not exactly a blockchain, not a linear blockchain. It is a DAG-based structure. So it is an unstructured graph of blocks instead of a blockchain. So you can see that one block, the one that's coming afterwards, does not need to pick one or the other. It has to reference both of these previous blocks that appeared in parallel, and then you just go on, and then another thing like this can happen. And that's why it is unstructured, because the blocks are not linear. They appear in this kind of interesting intertwined architecture, and the blocks can reference each other, and one block can reference two blocks from the previous cycle, and so on. And to manage this whole system and resolve any conflicts and order the transactions, and transaction ordering happens after the blocks are produced, Kaspa uses GhostDAG consensus mechanism. Just remember that block time is 1 second, all the blocks are kind of weighted equally, And the orphan blocks that would have been lost in Bitcoin as lost work are incorporated into the architecture of Kaspa, which is not linear, but is structured as an unstructured graph. And now let's go to Quai Network and how it resolves the orphan block problem, that is the issue that all proof-of-work blockchains are facing. It goes a slightly different route, and instead of weighting each block equally, like in Bitcoin and Kaspa, Quai Network understands that each block has a slightly different weight and a slightly different amount of work put into it. So at the moment, how we are thinking about blocks, and we used to think about blocks, is that they are all equal and we don't really differentiate between them. However, there is a bit more work put into some blocks and a bit less work put into other works. So they can all be valid, but some blocks, it is a bad way to say it, but can help you understand it, is a bit more valid than the other one. That means that a bit more work was put into one block than into the other. A way to illustrate this is just by going through the process of hashing and speaking about zeros. So every time the miners are solving a proof-of-work puzzle, they have to resolve and produce a certain type of hash. Hash is just a fixed number of symbols, of letters and numbers. And in that sequence of symbols, the first, let's say 10 or some number, arbitrary number, has to be just zeros. So the more zeros they are, the more difficult it is to produce a hash, because you just produce very random numbers and producing some kind of solution to the proof-of-work puzzle. But if you also need to have a certain number of zeros as a prerequisite, that is kind of more difficult to do, because the more zeros there are, usually the longer it would take you to find a solution. So let's say to produce a valid block and solve the hash, the proof-of-work puzzle, you need to have 10 zeros before your hash. So the first 10 symbols of your hash are 10 zeros, and then you have whatever the letters and numbers. Some miner can produce a block that is valid and has exactly 10 zeros, and then whatever the letters and numbers. Somebody else that produced the block almost simultaneously can produce a block with 11 zeros, so it is still valid for 10 zeros and whatever the numbers and letters there are. However, the second one, who produced the block with 11 zeros, put a bit more work into this block. This is visible and kind of understandable because it is less random of a block. The more consecutive zeros there are, the more work was put into the block because it is less random. The kind of entropy is reduced. So that's kind of the key thing of how Quai Network works. It weighs each block and the work put into each block intrinsically instead of treating each block as just valid. Instead of simply thinking, oh, this block is valid, this block is valid, it looks into the intrinsic weight of each block and how much work was put into it. And if slightly, a very tiny amount of work was put a bit more into one block, that is the one that Quai Network is going to choose as the dominant, as the main block, and that is going to be called as the heaviest chain rule. So instead of the longest chain rule in Bitcoin, you have the variation of that called the heaviest chain rule. And as for the internal structure of Quai Network, as you remember, in Kaspa we had an unstructured graph that incorporated the orphan blocks and could go into kind of different variations and shapes. Quai Network, on the other hand, thanks to this heaviest chain rule, does not have to be unstructured and goes into a very structured manner. And this, as you can see, is looking like this. You have a one base chain that you can see on top that is called the prime chain, that is the one that holds the full state of the network. Then the middle layer consists of region chains, and then the third layer consists of zone chains. Zone chains are where all the economic activity and any kind of transactions are happening. In the zone chains, you have 10 seconds per block. So Kaspa has 1 second per block. In Quai Network, it is 10 seconds per block. There will always be just one base chain with a full state of the network in Quai. However, the number of region and zone chains depends on the number of shards in a network. In the beginning, if you remember, I mentioned the process called sharding that allows the Quai network to scale with demand. So if you need more transactions per second, you can increase the number of shards, and that is done by increasing the number of region chains and therefore the number of zone chains that are within this network. So you can think of it as like layer 1, like Ethereum, then it has a bunch of layer 2s and a bunch of layer 3s that are going from each layer 2. So in Ethereum, you would need many bridges and many kind of protocols to make sure all of this interaction between the layers works cohesively. In Quai Network, this structure is built intrinsically and from the very beginning. It is the baked-in structure into the protocol. So instead of relying on bridges, this whole works without bridging and all the different blockchains can communicate with each other. That's it on the architectural part and a bit more about the technical part of miner extractable value. If you want to learn about MEV and what it is and whether you want it or not, you can watch this video. I'll leave the link in the description. But long story short, most blockchains have this MEV possibility for people to kind of inject transactions before yours and therefore earn money for that. In Kaspa, there is no mechanism to prevent this MEV from happening. That is not bad. Some people like MEV because they are the ones who are extracting the value from this. However, most people who are just regular DeFi users would not really like to have MEV on chain. And again, I'm not going to talk about what it is exactly because I'm not a professional. In Quai Network, there is a specific mechanism in place that can help prevent MEV. And I don't really know of any other blockchains that are trying to resolve this MEV to the same extent. And therefore, I just thought I had to mention it. And now a little bit about the mining and hashing of these blockchains. Both blockchains are GPU mineable, as I said in the beginning. However, they have different hashing algorithms. And that means that there are different types of computers that you can use to produce the coins for these cryptocurrencies. For Kaspa, the hashing algorithm is called K-heavy hash, and there are already ASICs for this kind of hashing algorithm. That means there are some efficient computers that have been developed specifically for this type of algorithm that people are using to receive the most effectiveness and the most value of mining Kaspa. For Quai Network, there is a different hashing algorithm that is PoW, and that is only GPU mineable, and that is an ASIC resistant hashing algorithm. That means that there is no ASIC for this kind of thing, and everybody who is participating has to use a GPU mining equipment to produce the coins for Quai Network. Depends on whichever one you prefer, of course. However, there is a lower barrier to entry for GPU type of thing, and for ASICs, you just go with the maximum efficiency, but with much more involvement from the miner side, because you have to invest much more into an ASIC. Now let's go a bit about the tokenomics. So for Kaspa, we have approximately 28.7 billion of KAS, which is a fixed supply with no plans to increase. There is a fair launch from November of 2021, when the long-term security comes from transaction fees. So at some point, the block reward is going to become very little, and therefore you will need some kind of thing to make sure the miners continue to mine Kaspa, and that is supposedly is going to come from transaction fees. So long-term sustainability of this kind of thing is a little bit questionable, because once the halving process, just like in Bitcoin, makes the block reward very minuscule and very little, for miners it does not really make sense to continue mining because they are not receiving much reward for it, and they are spending still a lot of money for this kind of hashing process. So what you could do, and for example, you could increase the emission, which is not very nice because you initially said it's going to be a fixed supply, people accumulated it, and then you went on and inflated the cryptocurrency, which is not good. You can add some kind of reuse of unmoved coins, which is a different type of mechanism that I'm not really going to talk about, but there are different solutions to this. And another way is just like increasing the fees for users who are paying the transaction fees in one way or another. Neither of these solutions is like perfect, and all of these are of course discussed by the Kaspa community, and whatever they decide, and how it goes. I assume it's not really a priority for them at the moment because this event is not like right now. So once it comes, I guess they'll have to do something with it, but not at the moment. Bitcoin actually has the same kind of problem. At some point, the fees for Bitcoin are going to be very minuscule for miners to kind of receive any kind of tangible reward from it. So it's going to be very interesting what is going to happen. For Quai Network, there is actually a mechanism implemented against this kind of thing. And there is a dual token system that deserves a separate video. That actually there is a separate video. You can go watch it. Also from Quai Network's CTO, Dr. K. And yeah, long story short, there is one token for saving that miners can choose to mine, and it has a limited supply. And there is another second token that is kind of for spending. It is an inflationary token and it does not have a fixed supply. And when miners are mining, they can choose which token they would like to receive for their rewards for the blocks. And they can pick whichever one during the mining process. And users also themselves can convert between the two. So if you'd like to learn more about this, again, watch the video or go read about the docs, both of Kaspa or Quai Network. And a lot of that is on Kaspa forums, actually. So you might have to go and have a read if you're very interested. Tokenomics of Quai Network. If you go a bit deeper, there is certain Genesis allocation, so it's not typical fair launch. There is a Genesis allocation that goes out in the first Genesis block, and that comes from people earning certain rewards during the testnet phase. So there are strategic partners allocations, there is an earn program that people are going for, exchange liquidity, testnet incentives, team founders, and foundation of Quai Network. However, this Genesis supply of about 3 billion is going to be just a Genesis, and then as miners continue to mine, this allocation is going to shift the percentages. So you shouldn't really pay all the attention to the Genesis allocation. It is of course important, but it's not the end deal, so to say. And yeah, that's kind of it for the tokenomics part. If you'd like to learn more about anything or have any questions, please leave me a comment. I hope I can answer any of your questions that you have. And as for the smart contracts, I already mentioned in the beginning, Kaspa does not support smart contracts, and that is because of its unstructured architecture. And their vision is that it is a community layer 1, whatever the community decides to do with it, they can do. And if somebody decides to implement a layer 2 on top of Kaspa that supports smart contracts, they can do it. And that's actually, I assume, is being done by some of the members or will be done in the future. However, at the moment, there is no support for the smart contracts. Quai Network, on the other hand, thanks to its structured architecture and thanks to its kind of a regular production of blocks, it is EVM compatible. Therefore, it's not only smart contract compatible, you can just go on and develop Solidity dApps on Quai Network. So the pool of developers who can come and develop on Quai is very large thanks to this. So in this regard, this is very much a good point for Quai and like 0-1 to Quai. If some points were kind of on the edge, the smart contracts, I think, are the key thing that is very important for cryptocurrency. Just since Ethereum launched with this possibility of smart contracts, it's kind of a loss not to have this functionality. Now let's have a quick recap TLDR. So Kaspa is like the digital silver if we consider Bitcoin to be digital gold. It is higher in TPS, so 400 versus Bitcoin's 5. It can go up to 2000. It is still proof of work, still very secure, and has a lot of good research behind it. However, the maximum number of transactions per second of about 2000 does not make it very usable as digital cash. That is still the niche that we need to have. And it is also not usable as a programmable layer for dApps and any kind of very fruitful DeFi activity, because at the moment, without smart contracts, it is very limited. However, we will see how it goes on develop in the future. Quai Network, on the other hand, is an all-in-one protocol, so it does not try to replace just Bitcoin and become digital silver like a faster version of Bitcoin. It aims to become both the store of value, so like digital gold, thanks to the fixed supply of one of the tokens, that's called Quai token. Then it can be digital cash, thanks to the inflationary token that's called Chi, and thanks to the support of smart contracts and very high TPS, you can go on and have all the possible DeFi activity on top of it, especially thanks to the EVM compatibility that it has. So Kaspa is like a faster version of Bitcoin. Quai Network is an all-in-one solution for the protocol. Kaspa is already in mainnet and you can already go and check it out. Again, no financial advice, and Quai Network is expected to go to mainnet around summer this year. However, no exact dates as of now. And other resources that I can think may be useful will be linked in the description if you'd like to learn more. Let me know if you have any questions. I hope this video was useful, you found it interesting, and yeah, see you in the next one.